Hi everyone, welcome back. More on trigonometry of any triangle, not just right angle triangles, any triangle. So I've already done 2 videos on the cosine rule if you've seen them, or you can go back and look at those. I start with the cosine rule. Years ago I'd start teaching with the sine rule. I still can do it today, most students are okay. But I've dealt with the cosine rule first. The reason is that later on there's some complications with the sine rule. So let's look at the easy ones for the sine rule. On these I wrote the letters A, B, C. We all walk in and write the letters A, B and C. And on this one over here I wrote different letters to make people brain up and see if they're okay with it. So let's have a look at what we'd write here. The rule comes down to, it just says A on sine A equals B on sine B. Now a lot of people like to write also equals C. This is capital A, so there's the capital A. If we go across from the capital A, we get little a. So there's little a. So the capital A's are the size of the angles, the capitals are the size of the angles, and the lowercase letters are the lengths of the sides. So we're talking about angles and length of the side. Let's have a look what's going on. This one here, if we go across from capital B, I get little b. So I've got 4 things to write in 4 places. What mucks people up sometimes is you might have 5 or 6 numbers there and they don't know which one to do, they get mixed up. Or there are some tricky cases, but we'll look at that later on. I'm going to replace the little a by the 15. I'm going to replace the big A by the angle of 52. I'm going to replace the little b by the letter X. Could have left it little b if you wanted to, wouldn't make any difference. I'm going to replace the capital B by the angle of 64. Don't forget to write the word sine in. It's not just 15 or 52. Now, there's so many ways I could teach this. It's not funny. I'm going to go this way this time. So if I had you here and I was tutoring you, I might say, what do you think of this method? And sometimes maybe a week later I'd go, well, what about if you did this instead? Or previously I've been brainwashing you, preparing you for this. But I have you on video, it's different. I want to get the X by itself. So we've got to divide by sine 64. That's in the way. We want this just to say the answer is. How do I get rid of a divide by sine 64? I multiply by sine 64. And I always talk about obs, the opposites to both sides. The opposite of divide by sine 64 is multiply by sine 64. Both sides. So if I write it on that side, I've got to write it on this side. Let's have a look at what we've got. A numerator, any numerator can cancel out with any denominator as long as it is straight above and below each other or it's multiplied. Cannot do it with division, cannot do it with addition and subtraction. So now this is left with just x. So just be a bit fussy for a moment. I'm going to write x equals and have a look at what we've got here. I've got 15 of those. So people will write the 15 first, sine 64. Then they'll write the sine 52 on the bottom. And you know, that's actually the answer to the question. So when we're looking at that question, then you can type it in your calculator. I'm going to say over here, please check those degrees. I've had year 12 students have their calculator set on the same thing. If you have a quick look at it, there's 3 possibilities. There's what's called D for degrees, there's R for radians, and there's G for grads. Grads is for the French system, their international system that they use, and they're talking about 100, instead of 90 degrees in the right angle, they're talking about 100. Instead of 360 degrees for a circle, they're talking about 400. Radians is for calculus in year 11 and 12, and a lot of people will come and do that later on. So be careful your calculator set on the wrong one, otherwise you will get the wrong answer. The numbers are stored depending on which type of system you're using. So have a look at what we've got over here. You just straight out type in your calculator. I've got the answer here. Turns out to be 17.1088 metres. That's to 4 decimal places. You can go to less decimals. You could go 17.1 or look at the rounding off and all that's going on here. Let's have a look at common sense for a moment. If this is 15 metres, I don't expect this to be 2. Even on a rough diagram on the board, I expect that to be some number like about 17. So there's your answer for that one. So it's just type that in on your calculator. Most people can show you that rather than be shown. Sometimes we'll have different letters written, sometimes we'll have no letters written, and you can pick whatever letters you want to write. So let's have a look what's going on here. Here's your capital G. Across from the capital G will be the little g. Here's your capital H, and across from the capital H is the little h. So we've got 4 things for 4 places. So if I wrote the rule down as letters, I'm going to go little g over the sine of capital G. I'm going to little h over the sine of capital H. Now if you're comfortable with this, as a lot of people are after a while, you don't have to write the letters, but let's write the letters for now for the people who like to write the letters. So I don't know what's going to go on for which people, so I give you choices all the time. So we're going to replace the little g by the letter x. That was nice, it come up first. And I'm going to write the capital G by the sine of 71. Or actually just writing the g as 71. The h is a 10, the little h that is, and the capital H is the sine, or is a 75, so it's a sine of 75. Just like we did over here, the opposites to both sides. I want to get the letter x all by itself. How do I get rid of a divide by sine 71? The opposite of divide is multiplied by sine 71. You might notice the way I'm writing, I always make that look like a numerator and that like a denominator. A lot of people write down here. Doesn't matter if they know what they're doing, but they can tend to make more careless mistakes. So if I wrote it on this side, I write this side as a sine of 71. So what happens? The top, the numerator, when you're multiplying or you're straight up and down, you can cancel. You can't cancel for addition across the fractions, and you can't cancel for subtraction. You can't cancel for division unless it's straight up and down. So what are we left with? Let's write it just to be fussy for a moment. You've got 10 of those, 10 of sine 71. So actually, just remember, this is the numerator, that's a numerator, that's a denominator. And I got the sine of 75 degrees. Now I've got the answers here, pop in my calculator. Just remember, make sure you're on degrees. Sometimes students want to annoy each other and they change their calculators, or you don't realise you've changed it. We need it to be in degrees, otherwise you will get the wrong answer and you get 9.79 centimetres. Now I could go more decimals. This time I went for 4 and this time I deliberately went for 2. Often it depends on what the teacher asks for, but in real life that's what you choose it to be. Let's have a look about what we've got here, see if it's realistic. So that's about 10. Come back up to here, this one was about 10, and this sort of looks like almost an isosceles triangle. If this was 10, that would be 10. If that turned out to be 1, or if it turned out to be 70 or 80, unless it was some really weird, long, skinny triangle, you know that you're probably wrong. Another one over. If you're enjoying them, let your friends know. Even if you want to press the subscribe, it's nice to get the encouragement. I'll see if I can find time to make it a lot more. Thank you.